This video will show how to show your data points graphically by plotting them in Excel, which may help in your analysis of data for the pendulum lab experiment. So this is a complete table already. It's a sample table with data, and you see here is a completed graph, and eventually we're going to show you how to build one of these things. So for those who aren't familiar with Excel yet and how to determine them, I'll just show an example first of a table without any calculation. So if you can see, you have varying angle of release here, and for each of the angle of release you have around 5 trials for here of period. The period here is measured in seconds, so maybe you should write it there. Okay. And that, of course, it's important for us to get the mean because that's the best estimate, or that best represents uh, what your period is for that angle of release. So in Excel, for you to be able to do that, what you can do is I assigned 2 columns here for mean and sample standard deviation. Let's start first with the mean. And to input an equation, you have here the on top of the toolbar or below the other options is an equation bar. So you click on the cell that you want to place the mean for, write an equation, and you type average. And then at this point, after you place your open parenthesis, you want to highlight all of the cells that you want to take the average of. So that's all of the 5 trials and the 10-degree angle of release. That should give you a result of 0.922. And then, of course, you're going to do the same for this one. So you're going to type average as well. And then you're going to drag everything again. And then you have that. Then again, you're going to do the same for all of the files or for all of the setups. Take the average here. And finally, take the average here. So here you have easily computed all of the means of all of the setups. But then I'll just show you an easier way to do that, because you don't need to repeat the formula or typing the formula for each of the steps that you do. So what you do is, so for example, you delete this. You check this small square box on the bottom right corner of the cell and just drag it down until where you want it to end. So it ends at 0.953, or it ends in the last cell, and it basically does the same thing for less effort. For the next one, you would want to know how widely these values vary on the sample standard deviation. So what you do is you type it as standard deviation in Excel as stdev. Then you would want to take the sample standard deviation because you only have a few data points, and then do the same thing. You drag, and then you complete it. So here you have the mean and the standard deviation of each of the data points in the sample. Okay, next, if you check the complete slide, the average and the standard deviation samples are presented clearer. So by clearer, I mean it has less decimal points. So for you to be able to do that, okay, we want 4 decimal points after, well, we had 4 digits after the decimal point, so we format the values. So we format the cells. Okay, once you right click format cells, you want to change the formatting of its number. So from general, that's the default, you place its number, and here you could actually specify how many decimal points you would want to represent your data. And for this case, it would be 4. You may want to check your data which one is the most appropriate. Generally, you want more than one significant digit in your representation of data. So here you have it. So that should give you a complete picture of the mean and the standard deviation, and for most of the reports that's actually enough. But then if you want it to be easily read for most people, especially your checker, you may want to graph your results. So we go on to the next part. Okay, so this may be the longest part. Here you have a generated title, but we're going to show you how you do it. Okay, so you would want to present the average period with respect to the angle of release. So that's one of the objectives of your experiment. That's one of the guide questions. And for you to be able to show it graphically, you want to insert a chart. So The best example for here is a scatter plot, and it highlights each individual point and its place in the graph. So you want your scatter plot here. So there's many ways to do it. The simplest one is first you want to highlight two parts or the two columns that correspond to the x and y axis. So that would be for the x-axis is the angle of release. So you just drag it as such. And then since average is far away, if you just drag it, it kind of includes everything else here. So for you not to include everything, I suggest, so after dragging this, you hold control and then you drag the same. So if you notice, we skipped out on the rest of the uh, cells here and just focus on two parts. Once you've highlighted it, you click the scatter, the simplest one, and you have a simple chart here. And if you notice, it's completely different from what we have now, or at the end of the day. So what you want first is, well, somewhat you want to clean the data, or you want to clean the real estate of the chart. You want to make sure that it's maximized. Generally, when you're reporting in, well, when you place it in the report, you don't want your chart title in the chart itself. So I deleted it, and it's best to be represented or labeled as a figure caption. Okay, next, I don't want, well, it's your preference, but generally I don't want to see any grid lines because most of the data is already represented in the table. If they want a specific representation of your data points, you should just check the table and not the chart. So for me, this serves no, well, it's a bit tacky in my opinion, but you may wish to remove that, as well as the vertical grid line. So you have an empty graph. Then next, what do you want to do? For someone who's reading your paper, that hasn't done the experiment yet, these points or these numbers may not be as clear. But then from the table, as you can see, the x-axis is the angle of release as well. The y-axis would be your average in terms of seconds. So you want to, or you want the reader to understand that. So for Excel, there's two options. You may want to check add chart element here or here. But then going to the chart tools, let's try to make it a bit more universal if you have an earlier version of Excel. You go to the chart element and then you go choose axis titles. There's the primary horizontal for the X and the primary vertical for the Y. We're going to put both. So we're going to type here angle of release. Then if you want to just specify that it would be in degrees, and you're going to add another chart element in the primary vertical axis. So you highlight it and you type in period, and it's measured in seconds. At least at that point, it's a lot clearer for the person to read it. Okay, now you visually represented it, and doesn't make sense yet because okay, there are a bunch of points. They look like it looks like a curve, and if you notice, it's not supposed to be like a curve because the angle of release is supposed to be independent from the period of oscillation. But then if you notice in the, well, you'll see later that when you make the trend line, it has a very small slope, and that slope was only accounted for by the fact that one of your data points is rather high. So we'll get to that in a bit. So the best way for you to represent the relationships between your data points, or the relationship between the x and the y axis, is to make a trend line. And the trend line usually tells you what the best fit line of the equation is. And since we're doing linear regression, it's best for us to represent it as linear regression. Okay? Uh, we'll discuss more of it later in class, maybe. But then for now, we're just going to focus on how we're actually going to show the trend line. So again, you go back to chart tools, design. We need to add another chart element. This time it's a trend line. And we want it linear because for most cases, we want our representation of data to be as linear as possible. Okay? So we have a line, but then it doesn't really show what the relationship between the two variables are. It just shows a line. So if you can see, the first three data points are rather close, and the fourth one is a bit far away from expected. So for us to make sense of this trend line, we want to add the equation. So we right click, we format the trend line, and on the right side, we have here a couple of options. So we already went with linear, and we want to set the equation in the chart to see how the points are related. Sorry. And going back to the trend line, we want to see its R squared value, or its Pearson squared coefficient. It tells you that, okay, we didn't I'm not sure if this was discussed in statistics and probability, but an R squared value closer to 1 means that your data points somewhat agree with the trend line. But then the lower its value, it makes it a bit worse, because that means they're not as related and you're just kind of forcing the trend line onto the point. So, uh, for most experiments in basic education in high school and probably elementary courses in college, a trend line of 0.9636 is, while it is not the best, it's somewhat acceptable already. And as you can see that the period here is related by this equation, 0.001 x plus 0.9102. So that goes to show you that there is some sort of relation between the period and angle of release. But then, even if it shows that there is a relation, it's rather bleak, or by bleak I mean it's unclear. So now you have a trend line that represents the relation between the period as well as the angle of release. And just go to show you that it's expected that you would have a rather complicated trend line, because it doesn't make sense for you to place high angles for the experiment that restricts us to use small angles only. So for example, in removing the 40-degree data point, so you do that by clicking on the chart and removing the highlight here. You notice that the R squared value becomes much higher, much closer to 1, and that you have a slope value that is much lower than previous. But then that's we don't want to do that, as that's omitting data already. So that's akin to academic dishonesty. You, as much as possible, unless you have a very good reason to remove that data point, you want to include everything there. Okay? But then we're not yet done. Okay, so we've graphed the trend lines already, but then how sure are we that it's acceptable, that the trend line here that we made is suitable for us to use based on the data points that we have? While average only shows you the best estimate, the standard deviation actually gives you a range of values that hold your measurements accountable. So, for example, in this part, here you have plus minus values here. So the bars that you see here are actually as long as the standard deviation values, depending on how widely your values vary on a specific experiment or a specific setup. So if you notice, the highest standard deviation here would be at 20 degrees, and the error bar would be largest. So in this way, I'll explain how to place the error bars in the next part. So to place the error bars, again, you go to design, you add the chart element, and you want to include standard error here. But then, as you can see, it kind of has a lot of points that you wish to remove. So for our case, you'd want to use the vertical bars more than the horizontal bars. So you want to remove the horizontal bars. You could highlight either of them. So you want to delete this part. But then it doesn't really, if you see, it's not really as consistent with what we have here. So what we want to do is we want to change the value of the error bars here to something that's more customizable according to the standard deviation. So you right click, again you right click the error bars, and you want to format it. You want both directions, so it's a plus minus range, and it's up to you whether you want a cap or you don't want a cap. Honestly, it doesn't really matter. So what happened? Going back to the numbers. Okay. Oops. Okay, going back. Here the error amount tells you what do you want to place. So standard error, I'm not completely sure how it works, but then if you want to be completely sure about it, you want to do it yourself. So the standard deviations are as follows. As you can see, they're not really the best way to represent it. So what you want to do is you want it custom. And from custom, you want to specify its value. For positive error values, it will be the same as the negative error values. And the convenient thing about Excel is all you need to do is drag it like so. and it would already correspond to each of the error or the data points that you already assigned previously. So those are the positive error values, as well as for the negative error values, you just highlight this and you completely replace it by completing it as such. Okay, so just want to remove this part. Okay, so you already have this, and again, if you want to place the caps, I want to return it. So I'll explain this a bit. So here our trend line shows that while the line doesn't completely hit the data points, as especially the third and the fourth point, for the first three you can see that the error bars encapsulate the trend line, at least for the first three data points. It shows you that while the average is not hitting the trend line exactly, it shows you that the standard deviation passes through the trend line, which makes it an acceptable value for the experiment. So here you have a standard deviation of 0.0039. This one is 0.0057. This is 0.0034. And finally, this is 0.0012. And as expected, you would have the 40-degree setup to not be part of the trend line because, again, our experiment is only restricted to small angle values. And a short note, this isn't the only way for you to represent trend lines. By all means, you could use constant value already. You can calculate the actual value of the period based on its length as well as its gravitational constant. And instead of putting a trend line, you could go ahead and remove the trend line already and just include that constant value. And then you want to see whether each of the single data points, after accounting for its standard deviation by adding its error bars, see whether it actually hit the period line, the constant value that corresponds to the theoretical period. So this is not the only way to represent the value. And one more thing, I haven't discussed this yet, but then for when you're representing, when you're already looking for the linear regression of the period, that's equal to the square root of L over G, you're going to want to represent a table that is, so for example, you have period here, and then you have length of the string as well as the center of mass. So you have dummy values, for example. They're not accurate, of course. So, for example, you have this, but then you know that period is directly proportional to the square root of the length. That's not going to work when you're going to place a trend line that is basically period versus length. What you want to do is you want a linear regression of period with the square root of length. So for you to do that, instead of superimposing length and period, you want to use the square root of the period. Again, this is very crude. Just shows you an example. So for example, you want to get the square root of this point, and then all you need to do is drag it down. And from there, this should be your linear regression already. Not the period, but rather the square root of period, because the theoretical equation is your period is proportional to the square root of length. So thank you for listening.